Good morning, sir.
So we'll just start our class. In the last class, we have completed, or we have just I have introduced about the principle of the EMF source. I have told you what is EMF source. Today I will tell you about what is actually happening inside this EMF source and how this EMF source is capable of developing an electric field inside a conductor connected to a load. Okay, so let us see what is actually happening inside this EMF source. And if time permits, we'll start with power problem. And let me tell you one thing, that today in the lab class, obviously I don't have anything to show you, so I'll be taking that class. But as I have messaged you that I'll be taking it from 2 to 3, and after that, Jagjeshwar sir will be taking your class because I have some work to go outside. So I have given him a class from 3 to 4, and he will be solving some left out problems. Okay, so please cooperate with him. Okay, so let us first start with EMF source and how it is actually working. We all know that your EMF source is basically going to create an electric field inside a conductor which is connected to a load. Okay, so I am having a load over here. So let us say I am having a load over here, and I need to create an electric field so that current starts flowing from this EMF source. Okay, so this is your EMF source. Let us say this one terminal is positive terminal and this one is negative terminal. Please take into account that this EMF source can be anything. It can be a fuel cell, it can be a battery, it can be a alternator or a generator, what we say, or it can be a photovoltaic cell, anything. But the principle is going to remain the same. So what is going to happen is that over here we have a load and we need this load to do some useful work. For example, suppose this load is a tungsten filament lamp, and it is going to when current is going to flow through it, because of this I square R, it is going to produce heat energy, which is again going to emit some light. So basically this load is going to do some work. So naturally, if it is going to do some work, I need to give it some energy. So from where it will be getting that energy? It will be getting the energy from this EMF source. Now the thing is that how actually this entire thing is going to work. Now the basic thing is that unless and until a current starts flowing in this load, work cannot be done. Now, current will flow only when I am maintaining a potential difference, or rather, I will say, if I am going to have an electric field not only inside the conductor but also inside the element of this load. For that, what I will do is that I will connect this EMF source through the conductors to one of the terminals of this EMF source. Now, even in this case also, the current is not going to flow because this is a open circuit. Now, just have a look over here what we have studied in the last class. In the last class, we studied that the positive and negative charges, they are all close to each other because they are attached to each other. Rather, I will say they are attached to each other because of the force of attraction. Now, what happens? Suppose I will start giving an external force. Okay, this external force, let us say that this external force is equal to Fn, and the force of attraction which is existing between them, if this Fn is greater than that, then obviously this positive and negative charges will separate from each other. So if they are going to separate from each other, then what is going to happen? Obviously, they are going to be aligned at different ends. That means all the positive charges will move to one side like this, and all the negative charges will move to the other side. So this is the case. So naturally, all the negative charges will be on one side and the positive charges will be on the other side. But at this case, when the positive and negative charges have separated from each other, then obviously what is going to happen is that inside this an electric field is going to be developed. Okay, now, but there is a problem. The problem is that every time these positive and negative charges are trying to come close to each other and neutralize their charge. But the problem is that there is a continuous supply of this external energy or force, which is actually keeping it separated from each other, right? So basically what happens, there is a force of attraction, let us say it is Fe, and there is a force Fn. Now this Fn is counteracting against this Fe, that is the force of electrostatic attraction between the positive and negative charges. Now, because this Fn is applied over here, therefore, the positive and negative charges have separated. Now, if they are separated, obviously they will move to the two different sides. So, all the positive charges will be on the top side, and let us say all the negative charges will be on the bottom side of this EMF source. Therefore, I can say that this terminal will be maintained at a negative potential, and this terminal is going to be maintained at a positive potential, and therefore there is a potential difference that is going to exist across the two ends of the EMF source. Now what happens over here? Just have a look. Now every time these positive and negative charges are trying to attract each other and they try to combine with each other. Okay, but now they are separated because of the continuous application of this force Fn. Now what is this Fn? This Fn is the force that is created because of some chemical reaction if the EMF source is a battery. Okay, if the EMF source is a battery, because of that chemical reaction, this force Fn is created. Similarly, if it is a generator, then obviously in this case, it is because of the mechanical energy that this force Fn is created, which is separating the positive and negative charges. Similarly, if I am having a photovoltaic cell, so in this case, what is going to happen? The light energy is actually responsible for creating this Fn, which is separating the positive and negative charges. Similarly, if I am having a fuel cell, then obviously in this case also some electrochemical reaction is taking place, which is producing this external force Fn. And again, if I am having, let us say, a thermocouple, it is the heat energy. It is the heat energy which is actually going to do the work and create this force Fn in order to separate the positive and negative charges. So I hope everybody have understood how this Fn is created. Now this Fn, or the external force, or rather I will say the non-electrostatic force, the proper name is non-electrostatic force, is actually acting against this electrostatic force Fe, which is trying to bring this positive and negative charges close. Okay. Now because of the application of this one, the positive and negative charges have separated. Now, as you can see, all the negative charges are on one side. So naturally, there will be a force of repulsion. Okay. Now, obviously, this force of repulsion and this force of attraction, they are going to aid each other. That means the negative charge will try to repel and try to move towards the positive charge. Similarly, over here, you are having a bunch of positive charges, and obviously, there will be repulsion on this side as well. So the positive charge will try to move towards the negative charge, and obviously they will try to combine, but they cannot do that thing. Why? Because of this force Fn. Now, so every time this positive and negative charges, they are facing two types of forces. One, because of the repulsion between them, and secondly, because of the presence of positive and negative charge, there is a force of attraction. So somehow they will try to manage to mix together. So how they are going to do that? Now just imagine, suppose I will complete this circuit by connecting or completing this circuit by means of connecting it through conductor. Now if I am going to do that, now you can see there is a repulsion over here, and you cannot move through this path to combine with the positive charge. So what is going to happen is that this negative charges will try to move through this conductor, and it will pass through the load. Okay, so when it is going to pass through the load, again it is going to pass through this conductor and it will come to this side, and over here one of these electron will start combining with this positive charge. But over here again there is a presence of this Fn, and immediately what this Fn is going to do, it is going to bring this, or it is going to throw this electron onto this side. Okay, so in this way, even if there is a circulation of this negative charge throughout the circuit and the negative charge is trying to combine over here, but still it cannot do it. Why? Because this force Fl is again going to act against it and it will dump it on this side. So this is a continuous process, and therefore these electrons will be moving through this conductor as well as this load. And when electrons flow, we can say that a current is flowing. And when current flows, the load is going to produce some energy over here. So as we have considered that this is a tungsten filament bulb, and therefore when the current is going to flow through it, it is going to give out light energy. And as you can see, inside this conductor also an electric field is maintained. Why? Because on one side of this conductor it is maintained at positive potential, and on the other side it is maintained at negative potential. So naturally the electric field is from the positive terminal or the positive side of the conductor to the negative side of the conductor, and in this way, so electric field is going to be in this direction. So the electric field is going to be in this direction, and we all know that the electrons will flow against the direction of the electric field. So number one is an electric field is created, so the electrons will move through this path. Secondly, there is a force of repulsion between the electrons, so the electrons will find another way to pass and mix with this positive charge, because this electron cannot move through this path. Why it cannot move? Because there is a continuous application of this non-electrostatic force because of the chemical reaction in case of battery or mechanical energy in case of generator. So this is the principle behind your EMF source and how it is actually going to circulate a current if the circuit is a closed one. Okay? Have you got this? Is there anyone with any sort of doubt? Yes? Yes, tell me.
No, sir.
Okay, is there anyone else who is having any sort of doubt? Because these things are very important to understand. So very simple thing, you have an EMF source. What is the use of this EMF source? This EMF source is actually creating the electric field in the conductor as well as inside the load. And therefore, because of the force of repulsion, the electrons from one of the end or the negative terminal of the EMF source will try to move through this conductor and the load, and it will be dumped at the positive terminal. But at the positive terminal, you will see that they will try to combine, but they cannot combine because the non-electrostatic force is again going to work and separate it as soon as it reaches the positive terminal. So this is the basic principle behind your EMF source, and as well as it is the basic principle behind the flow of current in a closed path. And I hope everybody have understood it. Is there anyone with any sort of doubt? Please tell me. I'll clear it once again. Okay, fine. Now let us move on to the next portion. So everything is written over here. So as I have mentioned that, so there is a force which is acting. This is force Fn is going to separate the positive and negative charges. This Fe in this diagram is the force of electrostatic attraction, which is trying to bring this positive charge towards the negative charge. Okay, but the principle is that because of the continuous application of this external force, these charges are separated. So they are getting another path to move. So inside this path, there is an electric field because one of the ends of the conductor is connected to the positive terminal. The other end of the conductor is connected to the negative terminal. So inside this also there is a existence of electric field, and moreover the electrons on this side are repelling each other, and therefore the electron will find a very easy path to move in this direction. So that is why we can say that when there is a closed circuit consisting of your load, consisting of your EMF source, and both of them are connected through conductors, then obviously there is a current in the circuit. Now, another important thing that I need to mention is that, okay, so here Fn, actually what is this Fn? It is the electrostatic force, which is non-electrostatic force, which is actually doing the work of separating the positive and negative charges. So that means this force is capable of doing some work. So let us say, as we know that work done is equal to Q into the potential difference, or rather over here I can write W is equal to Q, and I will introduce another letter. This is known as your E. Okay, but remember this E is not the electric field, it is the EMF, or the EMF that is generated because of this chemical reaction, mechanical energy, light energy in case of different types of EMF source. Now over here, when the electrons are moving, so whenever there is a movement, obviously there is some work done, and this work done is equal to your Q, that is the charge of the electron of that of the potential difference VAB. So in this case, if I am going to consider this EMF source to be an ideal one, what is ideal EMF source, that also I will tell you after some time. So in this case, this work is done, and the other work that is being done is the flow of electrons through the conductor and the load. So in these two cases, both the work done are same. So if that is the case, then I can say that the EMF generated by the EMF source, that is E, must be equal to the potential difference across the EMF source. So your E is equal to VAB, that is the potential difference across the two ends of the EMF source. Okay. Now, this equation is particularly valid for your ideal EMF source. Okay. So in engineering, it is not possible, it is next to impossible to have an ideal EMF source. Okay. Then we must be actually having a practical or real EMF source. So what is the difference between both of them? Now remember, when this EMF source is generating EMF, okay, so this source is generating EMF, and across the two terminals you are getting a potential difference. Okay. Now what is the problem? The problem is that in this case, inside this EMF source, there is some resistances, or there is some internal resistance. Okay, let me give you another example so that you can understand it easily. Suppose, let us say I am having a conductor which is made in the form of a coil like this. Okay. Then across this coil, I am going to connect some load. Okay. So let us say I will connect a tungsten filament lamp. It is a resistive load. Well and good. Now I will take a magnet over here with a north and south pole like this, and I will try to move it in this direction. Okay. So this is an infinitely long magnet, and let us say I am moving it, passing it through the center of this coil. If I am going to do that, then obviously this coil is going to behave like a EMF source. Here I am converting the mechanical energy into electric potential energy. So what is going to happen? Obviously, since this is a closed circuit, so naturally a current will start flowing in this circuit along with the coil. So naturally this coil is made out of some conducting material, maybe like copper or maybe like aluminum. So obviously copper and aluminum, they do have their own internal resistance, because every conductor, particularly metal conductors, they are going to have a constant resistance. So naturally that resistance is known as the internal resistance. Okay. So whatever be the EMF that is actually generated across these two points, or these two ends of the conductor, and the potential that is available across the terminals of the conductor, they are going to differ. Differ by what means? obviously in this case, your VAB, that is the potential difference that will be available across the terminal of the EMF source, is going to be equal to VAB is equal to E minus IR. Okay, when the load is connected, obviously a current I is going to flow, and obviously there is some voltage drop which is going to take place inside the internal resistance of the EMF source. Similarly, suppose let us say I am having a chargeable battery, and inside this battery I am having two terminals like this, okay, and I have used some electrolytes. So there will be a chemical reaction, and because of this chemical reaction, you are going to get some potential energy, or you are going to get a potential difference across these two electrodes. Okay, fine. Now you will see that when I am going to connect, means I suppose the I am going to connect this to a load like this. Okay, before that, before connecting this load, first what I will do, I'll measure the voltage across the EMF source, let us say by using a voltmeter. So let us say this voltmeter is giving me a reading of around 13.2 volt. Okay, now if I'll connect this load to this battery, then you will see that the current is now reduced to, let us say, 12.1 volt. So there is a drop of around 1.1 volt. So where is this drop? This drop is because of the internal resistance which is existing inside this EMF source. Now one can question that, okay, in case of generator, the conductor is there, the conductor is made in the form of coil, and therefore there is a resistance, and therefore we can say that is the internal resistance, and therefore there will be a drop. Now what in case of this battery? Now obviously in case of battery, something known as localization effect is taking place. What is that? Now you will see that when I am going to load this one, there will be a chemical reaction, and some sort of bubbles are going to form just near or adjacent to the conductor or the electrodes. And these bubbles are actually trapping some air, and in this way the resistance is going to exist between this inside this circuit. So this type of resistances are known as your internal resistance. Similarly, in case of photovoltaic cell, so you are having some photovoltaic cells, and inside this cell there is a problem that when light is falling on them, obviously there will be some resistance inside the photovoltaic cell as well. So that resistance is known as your internal resistance. So ultimately we can say that in case of ideal source, your whatever EMF is generated, that is always equal to the potential difference across the terminals of the EMF source. Whereas in case of practical EMF source, the potential difference available across the two terminals of the EMF source is actually less than what is actually generated. Why? Because there is a drop in the internal resistance. But an interesting thing is that when no load is connected, okay, so when no load is connected, in case of your ideal EMF source, E is equal to your VAB. Again, in case of no load condition, even in case of your practical EMF source, or rather I will say the real EMF source also, your E is equal to VAB. Okay, so this is a very interesting thing. That means when there is no load, your practical EMF source and your real ideal EMF source, both of them are going to adhere to this equation, that is whatever EMF is generated, that is equal to the potential difference across the conductors or terminals of the EMF source. But the moment I am going to give some load, in this case, in case of your ideal EMF source, your E is still going to be equal to that of your VAB. There is no change in the equation. Whereas in case of real EMF source, your VAB will be equal to E minus IR. So why it is so? Because in case of loading it, when there is a load and it is connected, a current I is going to flow. When it is not loaded, your I is equal to 0. So in case of practical EMF source also, your E is equal to VAB. So this is the main reason behind your or this is the main difference between your ideal EMF source and practical EMF source. But truly speaking, practical ideal EMF source never exists in our real world. So you can very well, if you are having a inverter battery at your home, that battery will be either a 12 volt, it will be a 12-volt battery. So you, if you are having a multimeter, you can just check it for yourself. So when there is no power cut, then this battery is not discharging or there is no load on this battery. At that point of time, you can take the voltmeter or the multimeter and check the voltage. And usually your voltage will be from 13.2 to 14.1 volt. Okay. So this is under no load condition. When there is no power cut, the inverter battery is not giving supply to the inverter or to the loads. But when there is a power cut, then obviously this battery is responsible for powering your inverter and the loads connected to it. In that case, you will see the voltage would have dropped to something around 12 or 12.1 volt. So there will be a serious drop of around 1 or 2 volt across the battery terminals. Why? It is because now since the load is connected, so current is flowing in the circuit, and when the current is flowing in the circuit, obviously there is some resistance or internal resistance drop inside the battery. So anyone with any sort of doubt? Okay, fine.
Sir, what is
Yes?
the difference between multimeter and voltmeter?
Okay, let me tell you one thing. What is the multimeter? Multi means it can be used to measure multiple number of parameters. So if you are having a multimeter, then you will see that it is going to have a screen like this, and over here you have a selection knob. So here you can either measure the voltage, you can measure the current, voltage, current, then you can also measure the resistance, you can also measure the capacitance, temperature, then something known as hybrid parameter for transistor. You can do continuity test. So over here, your multimeter is actually going to do a multiple number of parameter measurement. Okay, whereas voltmeter is only used to measure the volt. So this is the difference between both of them. Got it?
Yes, sir.
Okay. At any point of time, if you want, just remind me in any of the practical classes after this class, after today's practical class, I can show you a multimeter. I have a multimeter at my home. I can show you how it is going to be used. Okay. Next comes your ammeter and voltmeter. Let us give some or have some knowledge about this ammeter and voltmeter. Obviously, over here I'll just give you some superficial idea in order to solve the problems. But every detail about this ammeter and voltmeter will be taught in the next chapter. Okay. So what is an ammeter? Everybody knows it is used for measuring the current in the circuit. Rather, I will say it is used to measure current in a closed circuit. Why it is so? Because only in case of closed circuit, your current is going to flow. So the way the multimeter must be connected in series between the source and the load. Okay. Now you can see over here I am having the source, rather I will say an ideal source, and here I am having the load. So the current is going to flow in this path. Let us say the current is going to flow in this path. So I have to connect the I have to connect the ammeter in series between the source and the load so that the entire current flows through this ammeter. So when the current is flowing through the ammeter, then obviously it can measure it. Okay. Now, one important thing is that this ammeter must be having a resistance which must be equal to 0. Okay. So the resistance of an ammeter must be equal to 0 or as less as possible. Now, why is it so? It is because if the ammeter itself is going to have some resistance, then it is going to reduce the value of this current. Okay. Now, I am interested to suppose, let us say this is a 12-volt battery and I am having a load which is 6 ohms. Okay, it is a resistive load, let us say. I am interested to know how much current is actually drawn by this load. Obviously, we can calculate it to be 2 ohms. Doesn't matter. But now I want to measure it by means of this ammeter. So obviously the ammeter, if it is having a resistance of 0 ohms, then it is obviously going to show me a reading of 2 ampere. Now imagine if this resistance is not equal to 0 and this ammeter is having, let us say, a resistance of let us say 2 ohms. So if this is the case, then obviously this 2 ohms and this 6 ohms are in series, and therefore the current is going to be reduced. So the current is going to be 12 by 8 and your ammeter is going to give you 1.5 amps, which is the wrong answer, or which is the wrong current. Why? Because we are interested to know what is the current drawn by the load. So if the ammeter itself is having some resistance, then the reading shown will be less. Therefore, your ammeter must be, or rather I will say your ideal ammeter must have a resistance equal to 0. But the truth is that the ammeter is never going to be ideal. It is definitely going to have some resistance, but that resistance is going to be very, very less. So in the next chapter, we will do some calculations, and you people, for yourself, will see how the resistance of this ammeter is going to be very less. Okay, though it is not equal to 0. So four important things about this ammeter is that number one, it is used for measuring current in a closed circuit. Secondly, it is connected in series between the source and the load. Third thing, the ammeter must have a resistance very nearly equal to that of 0. Fourth one, it should be designed in such a way that it should not affect the measurement of current. Okay, that's the same thing. Next, let us learn a little bit more about this voltmeter. So this voltmeter is used to measure the voltage across any circuit element. So if I am having I want to measure what is the voltage across the load, I can measure it. If I am interested to find what is the voltage across the battery, then also I can measure it by connecting it in parallel across it. So here I am interested to know what is the voltage across, or what is the voltage drop across this load. Then I have to connect this voltmeter in parallel across this load. Similarly, suppose I want to measure the voltage across this real EMF source, then I have to connect it in parallel across it. Now obviously, in both the cases, if this one is not ideal, over here you will see that the voltage that is given out of by the battery is 12 volt, and over here it may be around 11.6 volt, even if both of them are connected in parallel. Okay, why? Because there must be some drop in the wires itself. Okay, so please be sure about this. Next, okay, problems we will do in the lab class. Now let us try to complete this chapter in theory. Okay, next thing that we need to learn is the energy and power in an electric circuit. Rather, I will say DC electric circuit, because AC power and DC power are completely different. So we'll only concentrate on the power consumed by DC circuits. Okay. Before venturing into this, we have to have some idea about what is a circuit element. So basically, there are two types of circuit element, even though I have mentioned 5 types, it doesn't matter. First one, the circuit element means what are the instruments or equipments or elements that are present in a circuit. So obviously in a circuit, there must be an energy source, or rather I will say a source of EMF. So this is the source of EMF, right? Next, what I need is I need a load. Okay, so a circuit element. So the load is also another circuit element. Now, this circuit element, this load can be a resistor, can be a capacitor, can be an inductor, or any combination of all. That means it can be RC, or it can be a RL, or it can be let us say LC or RLC, series or parallel. So there are multiple ways you can connect these circuit elements. Okay, but all of them are actually categorized under your load. So basically in one word I can say, or in one sentence I can say, that your circuit elements are actually of two types. One is the source, the other one is the load. And please note that your conductors are not circuit elements. They are simply connectors of these circuit elements. So regarding the circuit elements, you will get ample knowledge when you will study a paper on circuit theory in third semester. Okay. So we'll just limit our discussion to whatever is actually required for understanding these concepts. So as I told you that your circuit element is basically your source and your load. Now, every time, what is the need of this source? The source is used to give some energy to the load. Why it needs to give the energy? Because this energy will be utilized by the load to do some useful work for us. For example, if this load is a fan, then obviously it is going to rotate and create wind, which is going to give us comfort. Similarly, if it is going to be a LED bulb, or it is going to be a tungsten filament bulb, or maybe a CFL bulb, then obviously this is going to give out light energy so that it will remove darkness. If it is a television set, obviously this type of load is getting this electrical energy, doing the work of producing audio and video signals, light and sound energy. So every time we can say that energy from the source is actually transported to the load to do some work. Okay, that means work and energy, all of you know that they are both related, and rather I will say work done is equal to the energy consumed. But rather than talking about energy, because energy is some nothing but power consumed over a period of time. If it is a load, then we will say it is power consumed over a period of time is the energy consumed by the load. Similarly, what is the energy given by the source? It is nothing but the power which is generated or developed by this EMF source over a period of time. So at least we came to the idea, or we got the idea that energy and power, both of them are related to each other. Now, how it is related? In electric circuit, we are actually most of the time we are interested for measuring the power. Okay. For example, your LED bulb that you are using at your home may be a 5-watt bulb, maybe a 9-watt bulb, or maybe it will be 11 watt, maybe 20 watt, or maybe 18 watt, like this. So this watt is nothing but the unit of power. Similarly, your let us say water pump, you may be having half HP. Half HP is nothing but or 1 HP is nothing but 735 watt of power. That means when this pump is connected to the socket, then it is going to consume around 735 watt of power. Similarly, your 1.5 ton non-inverter AC is something around 1500 or 1600 watt. Okay, that means it is going to consume 1600 of watt instantly. Okay, so this is how actually we are interested, and in particularly in electric circuits, we are rather more concerned about this power, because depending on this power, we have to design the circuits. Okay, for example, suppose you are going to connect a LED bulb of 9 watt. Now in this case, you will never use 4 mm square wire to connect it to the source. Obviously, you will use a 0.75 mm wire to connect it. Similarly, if you are going to connect a 1.5 ton AC, then obviously you will be using some wire which is having a area of 2.5 mm square or 4 mm square. Okay, that means depending on the consumption of power by the load, we have to design the circuit. We have to see what should be the rating of the wire that we are going to use, what is the rating of the MCB that we are going to use, what is the rating of the fuse that we are going to use. So all this stuff needs to be taken care of when we are going to design a circuit. And for these things, these parameters, the knowledge of power is very important. Now, what is the unit of power? It is nothing but the watt. But believe me, watt is not the only unit of power. We are only dealing with the DC circuit. And in DC circuit, we are only concerned with watt. The only power is your active power, and its unit is watt. But when we will talk about AC circuit, there are 3 types of power. active power, reactive power, and apparent power, and all of them are going to have different units. So we are not going to talk about that right now. So we'll only concentrate our discussion to DC power. So as you can see, your P, that is the power consumed by a load, is equal to the voltage available across the load and the current it is drawing. That means suppose this one is a load. I have connected this load to a source. Okay, fine. Now I want to see what is the power that is consumed by this load. Okay, now over here there are three parameters over here. One, that is the voltage that is generated by this E, the voltage that is available across the load VAB, that is the potential difference across the load, and the current that this load is drawing from the source I. Now in this case, the power that is consumed by the load is actually given by VAB into I, not E into I. E into I is the power that is given out by this ideal voltage source, whereas VAB into I is the power that is consumed by the load. Please be very careful regarding this. Okay. Now, in case of DC, I told you that load can be resistor, capacitor, or inductor. But believe me, in case of DC, this inductor and capacitor, they are not going to consume any power. They are not going to consume any power. It is only the resistance which is actually going to consume the power. Why it is so? That thing we will learn in chapter number 30. Okay. For the timing, let me tell you, here in this chapter, in case of DC, we only consider that the resistance is actually consuming the power. So how much is the power? The power is given by I square R, or in other words, we can say it is V square by R. So I have missed out this by division sign. Okay. Next comes your power output of source. Okay, fine. Now, what is the power that is given out by the source? Obviously, the power that is given out by the ideal source, by an ideal source, P is equal to E into I. But practical source are the one which is actually available to us, because ideal is not available. It is not, it is hypothetical. So what is the power that is given out by a practical EMF source or real EMF source? Obviously, the voltage that is produced. Now you see, here I have drawn a rechargeable battery, and across this rechargeable battery, I have connected a load. Now, obviously, power is given out by this real EMF source to this battery. Now, how much is the power that is given? Very simple. Now, as you can see, that the power that is generated by this is E into I. But there is some power which is also lost over here. So rather I will say, we all know that VAB is equal to E minus IR. Now, as I told you that P is nothing but I times of the potential difference. So if I will multiply I over here, then I am going to get this equation. So P is equal to VAB I. Now VAB in case of real EMF source is E minus IR multiplied with I. So ultimately what I am going to get is EI minus I square R. Now this is the power that is generated or it is given out by the EMF source. Okay. Now you can see the actual power that is given out by this EMF source is actually what is the actual power developed or generated by the EMF source minus some power that is lost in the internal resistance. So a very common thing you can see, so most of you are having inverters in your house, and in your inverter you are having a battery, and you will see that when the battery is getting or the battery is delivering some power to the load during power cut, after some time if you go for, let us say the power cut is for a couple of hours, and after a couple of hours you go and touch the body of this battery, you will see that it is a little bit warm. Why it is a little bit warm? Because of this I square R, because inside the battery there is some internal resistance, and whatever power it is generating by means of the chemical reaction, some amount of that power generator is wasted in the form of heat. So that is the reason why it is getting a little bit warm. So if I am having a rechargeable battery, then obviously in this case, I am talking about a EMF source, but over here I have taken an example of a rechargeable battery. Now the power output of the battery is given at, or power output of any source is actually the power actually generated minus the power lost in the internal resistance. Next, what is the power input to source? A very controversial thing or something very ambiguous, or it is going to create some confusion. Why? Because yes, this source is used to give power. It is the one which is actually going to deliver power, and how it is going to consume power. Yes, very simple, because just like a battery is actually from the main supply. Okay, similarly the car battery or your bike battery. So when you are using or riding your bike, the battery is getting charged up. So during that time, it is actually getting power from the DC generator inside your car or in your bike. There is a alternator, and that alternator is giving power or producing electrical power, which is actually charging your battery. And when you are starting the car or your bike, or you are using the horn, or you are using the light or the indicator or the pass lamp or the brake light, whatever it is actually giving the power output to these loads. So that is why I have taken this example of a rechargeable battery. Now what is going to happen in this case? Now in case of a rechargeable battery, when it is getting charged, it is behaving like a load. Please be online. Oh, so अच्छा जब 42 42 मैं क्लास चलছি তো So in this case, what is actually happening? So this source is basically working like a load, because now it is consuming power to get itself charged up. So let us say the voltage that is developed across this generator is equal to VAB. Now this VAB is actually given to this rechargeable battery. So what is actually happening? So in this case, if I will say this one is minus and this one is plus, okay, and this one is the positive terminal of the battery and this one is the negative terminal of the battery. Now you put your KVL in this equation, Kirchhoff's voltage law. So from minus to plus it is VAB, then VAB, then from plus to minus it is minus, so it is minus E. Okay, the current is moving in this direction, so this one is going to be positive, so again it is minus IR. Now if I am going to take VAB to one side, then the equation turns out to be E plus IR. Now what is the power that is drawn by this battery to get charged? It is I times that of your VAB. So if I'll multiply I to this equation, so what I am going to get is this equation. P is equal to EI plus I square R. Now this EI is the power actually consumed by the battery to get charged up, whereas this I square R is the power lost in the internal resistance. That means when the battery is getting charged up or when it is getting discharged, every time some power is actually wasted in the internal resistance of the EMF source, or in the form of heat. So now if you will have a minute look at both these cases, so the first case is when the battery or the source is giving power to the load. In this case, you can see that the potential signs, potential symbols, here it is plus, here it is minus, here it is plus, here it is minus, but you will see the direction of the current to be in this direction. Okay, now just have a look at the other case when the source is itself working like a load. So in this case also there is no change in the polarity sign, but there is a complete change in the sign of this current or the direction of the current. It is just the opposite of the previous case. Okay, so always remember that when the battery is acting like a source, then the current is going to move from, or rather I will say, when the EMF source is behaving like a source supplying it to the load, then the current will always move from the positive terminal of the EMF source to that of the load. And the most important thing is that the EMF generated by the actually generated by the EMF source will be greater than the potential difference across the terminals of the EMF source. That is why please note these 2 points. It is very important. The most important thing is this one. That means whatever EMF is generated, that is always greater than the potential difference that is present across the terminals of the battery, that is VAB. So your E is greater than VAB. And in that case, if it is supplying a load, then the current is going to move from the positive terminal and towards the load. Next is when the EMF source is behaving like a load, then in that case also the polarity sign is going to remain the same, but the direction of current is going to change. And second most important thing, in that case, the actual power consumed by the source will be, that is E, will be less than the potential difference applied across it. So in this case, we will say that the power is actually being drawn by the EMF source. Is there any doubt? Boys and girls, are you having any sort of doubt? Please tell me. Because we have reached the end of this chapter. Only we are left with some problems which will start solving from 2 to 3, and 3 to 4 Jagjeshwar sir will be solving some problems for me, because I will be going out for some work. Okay. Now, is there anyone with any sort of doubt? Yes? No doubt. Yes, anyone with any sort of doubt? Tell me. Okay. Sushant? Sushant there? Are you online? Gurman? Gurman? What happened? Why you people are not responding? It is very frustrating to teach you people if you don't respond. So you
Yes,
are the
sir.
only one who is responding. What's the problem with others?
No, sir, there are a lot more.
There are a lot more. That is what is being shown on the screen. But really, it is very frustrating that when the teacher is asking, you people are not responding. What is this nonsense you people are carrying out? Huh? This way you are going to learn engineering? No interaction at all? So just be online and move away and do some other stuff in your house. What is this? It's very frustrating. Do whatever you like. My work is to teach. Everything is recorded. Huh? Even if I am asking anybody, nobody is responding. If at all you are responding as per your will. A disgusting thing. I'll leave it. You people are not going to mend your ways. That's very pathetic. So in the next class, we'll do some problems. So there are 3 number of problems we'll solve. Okay, by the way, have you got all the slides? All the 5 papers? Okay,
Yes,
fine.
sir.
No, today's lab will be not in a video. Today I'll be taking the class for 1 hour, the lab class, and another 1 hour will be taken by Jogeswaran Nanda sir. Okay. at university, and the photo is look.
Hmm. Hmm. Right. Looks like a church. Any other typical thing that you observed?
Mm,
Any
no,
typical? Sorry, Sudhanshu,
no,
not able to
ma'am,
hear.
not
Okay.
nothing very special.
Mm-hmm.
I
Okay.
only noticed that this university looks like a church.
Okay. Yeah, it does. Okay. So exactly. Hmm. Yes. Uh, okay. So anything related to that? What about others? No one else brainstormed on this?
Ma'am, you told us to find about that Glasgow University, no? I
Hmm.
remember.
No, I gave you a situation basically. I said that there's this man who wants to go to the University of Glasgow. He wants a direction for that, and he sees a woman, elderly woman, passing by him, and he asks her the way to the university. So the woman points out to a particular direction and says, "That's the university, and it's going to rain." Now, the man could not really decipher the meaning of "it's going to rain." He understands English, but he could not really find out or figure out why this woman said it's going to rain. So that's the situation, and I gave this situation with reference to one of the barriers of listening, which is lack of background information. Now, you gave me a lot of barriers. What are the possible barriers to listening? So some and there are some distractions, major distractions that we talked about. We also said that when listeners anticipate, when they jump to conclusion, when they focus more on the delivery style and the grooming of the speaker rather than the content. So all these are distractions. All these are major hindrances, obstructions to listening. But lack of background knowledge or lack of background information is also a major um, obstruction for listening. And it is in this context that I gave you this case, this situation. I told you to find out what could be the possible meaning of "it's going to rain." So, since I specified University of Glasgow, I wanted you to at least go to this site. I mean, find out how the structure looks like. Maybe, maybe the situation has some connection with the structure of the university also, the building.
Yes, ma'am. Yes, ma'am. I think I can relate. I heard from a friend, I guess, that they had a umbrella pool kind of something in the structure that which protects everyone from rain because in that area it's mostly rainy.
Okay.
Yeah.
Okay. So maybe Sudhanshu and Deep found out that the structure resembles, since it's an old university, the structure resembles more like a church, which has a tower. Now let us see what could be the possible meaning of that one sentence. It's going to rain, and why could the man not? really get the meaning of that. To understand or to decipher the meaning of that one line, "it is going to rain," you have to have these four background information. General factual knowledge. These are the four background information which is required to decipher the meaning of "it's going to rain." Number one is the general factual knowledge, which says that sound is more audible downwind than upwind, and wind direction may affect weather condition.
Excuse me, ma'am.
Yes.
Yeah, I just googled about that umbrella pool which I was just saying right now. It is written here that Glasgow's weather can be tricky to navigate, so the university has an umbrella pool to help protect everyone from Glasgow's ever changing weather.
Okay.
There are several umbrellas at the main gate and at the main reception, uh, Glasgow campus. Any member of the staff and or student can borrow these as long as the stocks last 24 hours a day.
Okay. That's a very interesting information, Gurman. Thank you. But had this been the case, the lady would have recommended the man, the man that you can borrow the umbrella from the umbrella pool. But she simply said, maybe as a passing reference, that it's going to rain. And why she said it's going to rain is has links with these four background information. The general factual knowledge is that sound is more audible downwind than upwind, and wind direction may affect weather conditions. So when it is downwind, there is a possibility, there is a probability of rain, and it was downwind. Now, when it is downwind, the sound is more audible, more clearly audible. Now, coming to the fourth point, knowledge of the context. You must understand where the conversation took place. So, the conversation took place about half a mile from the university. And like both of them said that the university has a tower. It's actually a clock tower. Deep. It's actually a clock tower. And the clock tower has a bell. You know, the clock tower has a bell. So while they were talking, the clock tower bell in the university was just striking, just ringing. So the sound was audible to the lady, and it was more clearly audible than other days, possibly. So she could make out that possibly it is a downwind, because in downwind the sound is more clearly audible, and since it is downwind, it is going to affect the weather conditions. So she inferred from the downwind, from the from the clock tower bell, which was just striking the hour while they were talking. And since it was just half a mile from where they were talking, she could hear the bell ringing. And she could make out that the sound is more clearly audible, and this could be possibly because of downwind. And from all this, she inferred that since downwind affects weather condition, it might rain. Now, the local factual knowledge is that the University of Glasgow has a clock tower with a bell. And the socio-cultural knowledge that we must know is that strangers in Britain, they frequently refer to the weather to oil the wheels of social life. Like in our country, we can talk to strangers about anything. But in Britain, possibly they don't talk much to strangers, and even if they do, they would simply refer to the weather. And that's why they have this form of greeting: good morning, good evening, good night. Uh, so these are the four background information that you must have to understand or to decipher the meaning of that one line, "It is going to rain." Okay, so all this information. Now coming to uh, after barriers, we have to understand what are the strategies, how we can enhance listening. Now this is a very interesting definition of bore. Bore is a noun here, is used as a noun. A person who talks when you wish him to listen. Now, what are the strategies we can employ to enhance our listening? First is keeping an open mind. So, effective listeners keep an open mind. Uh, because when you're listening to a point of view, to someone's perception, it is not the same as accepting that or agreeing to it. So, there is no harm uh, in listening with an open mind, because no one is compelling you to agree. You can simply listen. So, uh, when you don't have to agree to everything, then there is no point not listening. At least you understand what their perspective is, what their perspective is. Now, this can also help you cultivate a more open perspective and might help you to curtail your emotions also. So, keeping an open mind and listening helps you in many ways. This could also change your own perspective on certain issues. Second is come prepared. This is a very, very useful strategy, especially for classroom listening. When you come prepared to the class, uh, this this helps you to be better equipped in listening, because you know that uh, probably you would listen more keenly in the class if you are prepared, so that you try to fill out the gaps that you might have missed out. So you listen in order to see what the teacher tells you in the class and what you have read. What is your understanding of it and how the teacher explains it. So coming prepared to the class is a very useful or very important strategy for listening. Now we are talking about listening. Now this will definitely compel you to listen, because you know you have prepared the lesson before and you would like to find out where are the gaps. What does the teacher say about a certain concept? And what is my understanding of that concept? Does it match? If it doesn't, where lies the difference? And how can I fill up the gap? Right. Uh, Coming prepared to the class also helps you in seeking your doubts, seeking answers to your doubts and queries, because you know where you have a doubt and you can ask that in the class. So this is a very, very useful strategy to come to the class, coming prepared. Now, when you come prepared to the class, to the lecture, you are more engaged in listening. because then you don't get distracted easily. If you don't come prepared, then you don't really care. How does it matter anyway? Our teachers are going to send us all the PDFs, all the notes, everything. So how does it matter if we don't listen in the class? But if you come prepared with, if you have read the unit beforehand, you know what your teacher is going to teach you in the next class. So when you come prepared with that, you don't get easily distracted. You'd like to listen to what the teacher is saying. So you are more engaged. You're deeply engaged in listening because there are many other purposes that you need to accomplish. One is filling out gaps, finding out where the difference lies in both your understandings, seeking out solutions for your queries, and you're also better able to adjust. You're better able to perceive things. If you don't come prepared, then probably things might get a little difficult for you, and then when things turn difficult, uh, we are distracted. We don't have the patience to listen and understand. We don't listen. Uh, so coming prepared to the class is the is the best strategy. I think. The third important strategy is taking notes. Now, when you're taking notes, you hardly get distracted because you have to focus on what the speaker says, summarize it mentally, come out with the key ideas. Because you taking note doesn't mean you're writing a shorthand like secretary. Taking notes means evaluating everything, understanding, and then churning, sieving, and then coming out with the key ideas. So you're going to write the key ideas, the major and the minor points, not everything that the speaker says. So when you are keen on taking notes, you will never get distracted. So this is also a good idea of listening. Now we are discussing strategies to develop or to enhance our listening. So coming prepared is a very good strategy because then you try this out. Not only for this subject, for other subjects also. You try coming prepared to the class beforehand, what the teacher says. Come prepared, and then you see how keenly you tend to listen to what the teacher says. And the second most important strategy is taking notes. When you're taking running notes, even if it's an online mode or offline class, if you have the habit of taking notes, not everything that the teacher writes on the board we start writing. That is not taking notes. Taking notes is listening to what the instructor says, summarizing it mentally, coming out with the key ideas. So initially, I've been telling this repeatedly that listening and note taking goes together. Both of them go together. And in listening, what is important is, since it is a mental activity, listening should make you find out the key idea of the speaker. So, one of the basic purposes of listening is to find out the theme, the main idea, the key idea of the speaker, like in reading. In reading, when you're reading, what you do is whatever the theories are, there are many theories about reading. But whatever the theories are, like one of the theories propagates that reading is like peeling onion. So when you peel onion, do you find a seed inside? Do you find a seed inside onion? Yes, no? Yeah. So you don't find yeah, Sutosh Ranjan, why have you raised a hand? So you don't really when you peel an onion. Yeah, Satosh, you want to say something?
No, ma'am, by mistake.
Okay. You don't find anything. So they propagate the idea that reading is like peeling onions. So you keep reading and you don't find anything in between, in the center. But whatever these theorists say, the basic purpose why we read is to find out the central idea, the theme of the book, isn't it? Similarly, in listening, why do you listen? Because you want to find out what is the key idea of the speaker. What does the speaker want to say? And that is accentuated through note taking. By note taking, I never mean that you have to write down everything word by word what the instructor says. Don't. Or what the teacher says in the class. Don't do that. That's not note taking. Note taking is understanding the difference or finding out the distinction between the key ideas, the major point and the minor point. And when you're able to do that, you are a very well equipped listener. So you just have to write down, take down what is important. Sometimes what happens when we are listening, we find something very interesting, a particular phrase or a particular word that the speaker uses in a different context. So we can take note of that also. There are interesting phrases that speakers come up with. So we can take a note of that. That's for our own enhancement, enhancing our own vocabulary. But besides all that, note taking is a very subjective thing. So, besides all that, why you must take a note is that this never interferes in listening. Note taking never interferes in listening because you are not uh, writing down everything. Because if you listen too hard and try writing down, then you're not listening, your listening stops. So, listen, try to find out the key ideas of the speaker, write down the key ideas because very often what happens is we tend to forget them. The moment we come out of the lecture, of the talk, or of the class, we tend to forget most of the things. So taking notes reinforces your memory. It helps in retention of the memory because it is written down. So you can go back and refer to your notes, and this kind of replenishes your memory. So note taking is not writing down word by word or writing down everything the teacher is writing on the board. Note taking is listening, summarizing mentally, and distinguishing the key ideas, writing down the key ideas so that we don't tend to forget it. So that when we go back and refer to our notes, things are again afresh. So, learning to focus your attention on main points. Yeah, this is what I've been telling you, key concepts, and gaining the overall gist of the speaker's talk is something you need to develop. And taking notes helps you in doing all this because you're definitely going to write down the key idea, the key concepts, and mentally summarize what the speaker says. Sometimes you can write down interesting words or phrases that the speaker uses. And so you might do this by jotting down a few notes or draw visuals that help you recall the main ideas. So the purpose of note taking is to help you recall the main ideas. And what are the listening tips? And who's reading this for me? Who will read this? Okay, good one. Where are the girls? The girls are all busy studying for the quiz. No one is in the class.
They, I mean, their names are here.
Sorry, Gubman. Can't hear you.
Some girls are here, but I don't know, they're not responding.
Yeah, they will be busy reading for a quiz.
Maybe.
And that's, at the last moment you don't really remember a lot of things.
Yes.
Remembering and memorizing doesn't happen at the last moment. That is not how our brain functions. So, the last moment when you start reading or preparing for the exam, it's not much of a help. So, if you constantly and continuously read, okay, Gopal, go ahead, please read.
Yes, ma'am. Listening tips. Be prepared to listen by keeping up to date with your textbook reading. Read the chapter before the lecture. Determine the main idea and all important details that will come in connection with it. Learn to recognize that the speaker is making by an important point by pausing, giving examples, repeating what's been said, repeating the textbook, increasing volume or changing pitch of voice, taking more time on one area, adding class activities or worksheets, using body language such as facial expression, gestures, postures, pace, writing on the chalkboard, statement, or signal words, example, significant, most.
Okay, thank you. So, these are some of the listening tips. Number one, very important, come prepared to the class. Next time, try this, not only for CTC, but for other subjects as well. Try coming prepared to class and then see how your listening enhances manyfold in the class. How you are really interested in listening. How you're keen in listening to the class, to the teacher. Read the chapter beforehand. The prepared is a very important, one of the important checklists of listening. Number two is find out what the main idea is. When you're listening, try to find out what the central idea, what the main idea is of the speaker, and how is he relating the main idea with uh, other subsidiary ideas. And how do you know the speaker is making an important point? The speaker gives in a lot of cues, vocal cues, non-vocal cues, a lot of pointers or signposts. Uh, for example, the speaker might pause. So when the speaker is pausing, that means he's trying to make an important point or gives a lot of examples, tells a point and then suffices that with a lot of examples. So that's a pointer, that's a signpost. That this could be one of the key ideas. Because he is trying to give in lot of examples to suffice that idea. Repetition. Repetition is something which all the teachers use. We keep repeating every now and then. We keep repeating important ideas every now and then. And I especially ask you to recapitulate everything. Most of you, since you don't take a running note, you don't know where we have left. And this vanishes from your mind because words are volatile. It vanishes. So you keep a written record. So repeating, that's a signpost. Repetition. We repeat key ideas, increasing the volume or pitch of the voice. Either the speaker increases the pitch of the voice if he's trying to suggest the central idea, or speaks a little slower. There's a change in the pitch of the voice. He doesn't speak regular pitch that he uses. He slows down, or speaks with a raised voice. Taking more time on one area. If I took more time on ethics, that means this is important. Adding class activities or workshops. So these, all of them are pointers that the speaker is trying to make an important point. If I'm giving assignments on certain areas, then I consider that important, because I don't give you follow-up exercises for every chapter. I gave you for ethics, I gave you for claims, I gave you for argumentation and critical thinking. So broadly, I tried to cover up everything. And the follow-up exercise for listening was the documentary that I made you listen in the lab. There are other associated activities with that, but since I'm not able to see you, I'm not able to observe you physically, I'm not able to give you that. So when we add class activities or worksheets to the ensuing chapters, that means it's important. Using body language or writing on the chalkboard, or using direct statements like vocal statements, vocal pointers. This is important. So students, please write down. So don't teachers say like this in the class. Please take a note of this. This is important. This is coming for your exam. Read this. This is important. Significant. So these are signal words. So they help you to understand what is important and what is not. So you just have to be a little keen in finding out what are the signposts that the speaker is using to show us the important points, the key ideas. So try to recognize the signposts, whether in reading or in listening. So recognizing or identifying the signpost or signal words, pointers are very, very beneficial. Then you get to know that this is, this is important. Usually in the classroom, the teacher says that this is important, take a note. Now these are very direct signal words, but even if the teacher doesn't say that this is significant, there are other ways in how the teacher points out, how the teacher makes pointers for key ideas, crucial concepts. And these are some of the ways in how the speaker tries to make an important point. So you need to learn these, learn to recognize these signposts. If the teacher is taking more time in one particular area, in one particular topic, then you understand that this is important. Now, how will you focus your listening? So listen for main ideas. So what are the main ideas that I talked about in listening? What do you think were the main ideas? What was but what was the most crucial thing that I told you about listening?
Take out the important points that the instructor said.
Exactly, exactly. So Ashutosh Ranjan is a very effective listener. Good, Ashutosh. You're a very effective listener. because I've been repeating this every day in the class. That one of the vital competency, listening competency, is to recognize the key ideas of the speaker. So a good listener must be able to mentally summarize what the speaker says and should be able to distinguish the key ideas. That is what the job of the speaker is, like the reader. The reader ultimately, even if we propagate so many theories about reading, ultimately the one most important thing about reading is you read because you want to comprehend, you want to try to find out the main idea of the writer. That is why you read. Yeah, in the coming weeks, we'll start doing all this. So Deep just put in a message in your group that that all of them must be able to fill out the reading journal. I'll start it uh, maybe after the coming week. And then the presentations, the PPTs, and the uh, persuasive speech. So all the three activities will be started in very few days. So please inform your fellow mates. Put that in the group that they must be ready with the PPTs. Uh, okay. Okay, so I'll teach you visual aids first. Maybe after listening, we'll talk about speech making, and then towards the end, we'll do audience analysis. Okay. Hmm. But just inform them that try to. They just have to fill out the reading journal. Yeah, yes, they'll have to read out the review that they have done about the book. I'll tell all this in the lab. Hmm. Just prepare everyone um, for these activities. Let them be initiated. Yeah. Okay. Yes. So most important point about listening. That one of the core competencies is be able to mentally summarize and find out the ideas of the speaker, distinguish the key ideas of the speaker. Uh, some of the minor points that I said, uh, some of the minor points. Okay, sorry, there was a problem, so I just got. So continuing with that, and the other points that I told you was that to enhance your listening, the two most important things that you need to do is you must try this out for all the subjects. Come prepared, at least for one chapter, for one class. Come prepared because you might know what teachers are doing. So maybe for your DSA class or for calculus class, come prepared beforehand, before what the teacher is going to teach you. Come prepared with that and see how you are so keen, how you're so eager to listen to what the instructor is saying. Try it for yourself. Don't believe what I'm saying. Try it for yourself. So the most important point, the strategies of listening, is coming prepared to the class. This will enhance your listening manifold, because you'll be really keen to listen to what your instructor is saying. The second thing is taking down notes. So the three key ideas of listening, the three takeaways from listening is, if you are a keen listener, how do we know that, or how do you know that you are a very keen listener, or that you have a good listening competency? Number one is that you can mentally summarize what the speaker says and uh, distinguish the key ideas of the speaker. Number two, to enhance your listening, you need to take notes, because listening goes with note taking. Both of them go together and you can't separate them ever. So if you're not taking notes, that means you're not listening. You're not a good listener. And note taking doesn't mean writing everything. Okay, Swayam Jyoti, are you listening? Swayam Jyoti, are you there in the class?
Yes, ma'am. Yes, ma'am.
So you must or a notebook, journal, whatever you must with you all the time. When this girls, if you are listening, I don't know. So you must, I don't time of pencil and things that you keep with that mascara, lipstick. You must have a writing journal and a pen in your bag. This comes very handy. Oh, great, Akansha. So, because I couldn't hear any of the girls in the class, so I was just assuming that probably you're not. Anyway, if you do, then besides everything else that you carry in your bag, please have a writing journal and a pen in your bag. Even everyone, irrespective of your gender, because this helps. This comes handy. And doesn't mean writing everything that you listen, finding out the key idea and then writing. So with listening goes note taking, like bread and butter, like knife and fork, like pen and paper. Listening and what goes with listening?
Taking notes, important.
Yeah. Listening and note taking, both of them go together. So the next time onwards, please have a notebook with you, a journal with you, a writing journal and a pen. Even if the instructors are not able to see you, even if we are sending you all the PDFs, you must have a writing journal, because whatever I say in the class is not exactly or reflected in the PPTs in its entirety. There are a lot many other things that I say, even for the other teachers also. They might be telling you a lot of other examples and other things. And there could be a lot of interesting concepts that you'd like to take a note of, which is not replicated in the notes. So the classroom cannot be replicated all the time. Classroom is a very living place, because it is interactive. It's not a dead place. It's living, it's organic, because we interact, and that is a spontaneous teaching and learning process. And it's a mutual teaching learning. So it's not that I am the teacher. No, it's not like that. So we mutually learn from each other. I learn something from you. You learn something from me. So it's a very lively, bubbly, organic place, and this cannot be replicated elsewhere. So it's important that you have your writing journal and a pen. In a physical classroom, I simply make students get out of the class, those who don't have a pen, and those who don't sit by opening their pen and their notebook. because I believe that's the basic classroom etiquette. When you sit in a classroom or in a lecture or in a talk, you must open your notebook and a pen. Because if you don't open your notebook and a pen, that means you don't open your mind also. So listening, note taking go together. It's a must. So listen for main points. Listen for evidence. If it's an argumentative talk, if the person is arguing, which most of you would be doing in the upcoming classes, you know, look for evidence. Listen for evidence, and ask these questions: is the evidence accurate? Is it taken from objective sources? Is it relevant to the speaker's claim? Is it sufficient to support the speaker's points? So you must listen for evidence if it's an argumentative talk. But if it's a narration, if someone is narrating a story, you don't have to look for evidence. And listen for the technique. What is the technique the the speaker is using? What are the techniques that the speaker uses? So listen for. Is it like by 12:50 your attendance is done or something? I'm really keen to know. Is it like before 10 minutes your attendance is taken? Why is it that just before, during the 10 minutes, every one of you start leaving the class? It's like before 10 minutes, attendance is done. So your work is done and you can leave. Is it like that? I don't
No.
know. Oh, that's good then. Because I find students, yesterday also I found that by 12:50, I don't know what could be the possible reasons, hunger pangs or...
Ma'am, data packs existed maybe.
By 12:50 your data is exhausted. By 10 to 12:50 your data is exhausted.
Some people's.
Okay. And I don't understand, since all of you are at home, so why can't you use your Wi-Fi like? And this is what we were talking about also. No? But by 12:50, if your data is over, then I don't know. The data should continue till 4 at least. And now you also have a quiz from 5 to 5:30, or whatever the time is. Okay, so listen for accuracy of the evidence, for objective, whether the evidence is taken from objective sources. I think if you can recall when we were doing the chapter on evidence, whether it is accurate, whether it is objective, whether it is even relevant to the claim, connected to the claim, and whether the evidence is sufficient enough to support the speaker's point. And listen for the technique. What is the technique that the speaker is using? How has he organized the talk? What is the organizational pattern of this? And what are the 10 ways of improving your listening? The fourth and the fifth point are important. Be flexible in note taking. You can use graphics, you can use shorthand, abbreviations. Listen for ideas, main ideas, central facts, organizational patterns. Very important. Find area of interest. So what you can do is maintain eye contact, even if the subject appears boring. So I tell my learners in the class that even if you're not interested in some subject, now things are different, but in the physical classroom, you had no escape. So all of them had to sit for 1 hour. So I used to tell them, even if you're not interested in a particular class, it so happens, not possible. We are all human beings. So not possible that we'll be interested from 10 to 4 every day. Sometimes we might feel bored. Sometimes we are preoccupied. Sometimes physiologically distracted. But whatever the reason is, I tell them that you can always pretend to listen. So pretending is when you maintain eye contact with the speaker and behave non-verbally as if you're very keenly listening to the speaker. So the speaker is happy, you are happy, so everyone is happy. So sometimes you can pretend to listen, and this could help you to actually, when you're faking to listen, this could actually make you listen at times. So when we are not judging the content and the delivery, so finding out what the speaker knows and not how he presents it. Uh, Most importantly, don't listen defensively. Don't get preoccupied with rebuttal. How am I going to rebut the speaker without listening? Listen first. Then, if you have some genuine queries, ask that. But don't listen defensively. Don't get ready with your rebuttals before listening. And listen for ideas. Be flexible in noting. Work at listening. You have to really work at listening because listening is hard work. It's both physiologically and mentally difficult work. So spend some time as to how you can give attention to listening. Basically, it's kind of a meditation. It's a meditation. Listening is also kind of meditation, where you resist distractions. There are a lot of distractions, I know, and you're fighting your own battle at listening. So resist those distractions. Uh, Exercise your mind. Try to listen to varieties of things, not things that only interest you. So you can always challenge your mental capacities to try to listen to a variety of things. Keep your mind open. Be careful of emotional impact or emotional trigger. You've just recently broken up with your girlfriend, and then uh, the speaker talks about love, trust, and then it creates a trigger, emotional trigger in your mind, and you become emotional. You get preoccupied and not listen to what the speaker says. So don't allow emotional triggers. Don't start getting preoccupied with rebuttals. Don't listen defensively, and capitalize on thought speed. If the speech speed is 200 words per minute, the thought speed could be 500 words per minute. So capitalize on that. Any queries, last minute queries? No? No queries? How is it that you don't have queries? Either you are not listening, one possibility. The second is that you have understood everything very well. I doubt. Uh, what is it that, or you agree to everything that the speaker says? Three possibilities. So which one would you tick mark? Because you don't have any doubt. Oh, you agree to everything. Okay. Okay, so what's your exam today? What's your test today? What test do you have today?
Today we don't have any test. Tomorrow we have characters.
Oh, okay, okay. Good luck for tomorrow. Uh,
Thank you.
Thank you all.